Okay, 8-4, negative exponents. The big idea, the takeaway is the numbers raise x to a negative power and x to the n are reciprocals. What we've got is for the negative exponent property. B to the negative n is equal to 1 over b to the n. So if I had 2 to the negative third power, this is equal to 1 over 2 cubed. Now, if I looked at this as 2 to the 0th power over 2 cubed, remember our work from the last lesson, this is 2 to the 0 minus 3, which is equal to 2 to the negative 3. So that's what this is telling us. We can write it as a negative power, but it means 1 over that, or the inverse of it, as we'll see when we look at some later work. The negative exponent property for fractions, well, I just mentioned that, is the inverse. So if I have x over y to the negative n, it's equal to y over x to the nth power. So if I had 3 over 4 to the negative 2 power, this is equal to 4 over 3 squared. Okay? Let's try some and see how this works out. I think you'll find it all comes pretty quick. For example 1, we're asked to rewrite c to the negative 8th times d squared without negative exponents. Well, c to the negative 8th power times d squared, that's going to be c to the negative 8 is 1 over c to the 8th power times d squared. I want to put it all in one fraction bar, so that's d squared, because d squared times 1 is d squared, over c to the 8th. I've rewritten it without negative exponents. I can't do anything with the c and d. These are different bases, so I need to stop at that point. Let's look at guided example 2. This is in your book, and it asks write each expression without negative exponents. So these are fractions, and remember from our property, negative exponent property for fractions, I simply invert this. So 5/4 raised to the negative 2 power is 4/5 squared. And well, let's go ahead and we can finish this off. We can simplify it, right? So 4 squared is 16, 5 squared is 25, so that's 16/25. How did we get that? Well, we learned that last time, right? That's 4 squared over 5 squared. Okay, for b, 1 over m squared to the negative 3 power, that would be m squared over 1 to the 3rd power. And now we have a power of a power, so that's 2 times 3, and that would be 2 times 3 is 6, is equal to m to the 6 over 1. I don't need to write it. It's simply m to the 6th power. Okay. We can also use this to solve some of the problems that we've seen in the past. 5 years ago, Molly bought a 60-month certificate of deposit that had an annual yield of 5%. Now, how many times does 5 go into 60? 12. 5 years is 60 months, right? So she's now done with it. The certificate of deposit is something you put it in the bank, and you guarantee to the bank that you will leave it there for that entire time. In return, they generally pay you a higher interest rate because they know that money is available to them. so it has more value to them than a regular savings account. That's what a CD is. So it's now worth $1,914.42. Well, how would this work out if we wanted to get this done? We know that the principal is, well, we had 1,914.42, and we want to know what it was in the beginning of time, and this is times 5%, so times 1.05. 1 is because we want to multiply it times the amount that was there in the first place, and 5% is our rate of return. But now we're going back in time. So to go back in time, we are using a negative power, so raised to the -5 power. So we can run that through our calculator, and what we get, $1,500. So that takes us back in time. We took as the principal the amount earned, multiplied it times the principal and interest raised to a negative power, however far back we needed to go, and the result was about $1,500. That's example 3. Let's take a look at our next example. And here is example 4. Guided example. This is in your book on 477. It said simplify this expression and write the answer without negative exponents. So much as we did previously, we want to work with each base and bring them together. So I had 5 over 15, a to the 4th, a to the 11th, b to the 7th, b to the 5th. It's nice. They had them organized for us already. They're kind of a little OCD like me. So 5 over 15, that 5 goes into 5 one time, 5 goes into 15 3 times. And this is times a to the 4 minus 11. So 4 minus 11 is going to be a -7 times b to the 7 minus 5 is going to be 2, so b squared, times c to the 2 minus 3 is a -1. So I've now got this as 1/3 times a to the -7 b squared c to the -1. I need to rewrite it without negative exponents. So I have a 3 in the denominator and a to the 7th. B squared is in the numerator, and c to the -1, which is just c to the first power in the numerator. And I have now rewritten the expression without negative exponents. Well, what happens when we work with a negative exponent in a power-to-power situation? Well, we remember our rules of multiplying. A negative times a positive is a what? Right, yeah, negative. Negative times a positive is a negative. So k to the -3 raised to the 4th power is k to the -3 times 4. That's k to the -12. And there we've got our, oh wait, right, without negative exponents. So we're not done yet. We need to rewrite that without negative exponent. So that would be 1 over k to the 12th. That's our answer without negative exponents. Okay, that's it for 8.4. Next video we'll cover 8-5. We'll continue with the pacing on this. The mastery quiz for these will be for 8.4 and 8.5. Once you're done with both of them, see me about the mastery quiz. Okay, see you in class. Bye.